at least I guess there are some master study program only in computer vision. So that is not easy to cover all this topic, but I try to work hard to offer a few the basic and the main fundamental. Then we go to how to implement algorithm, how to use the openCV library, the main library we use, and also we prepare also some many exercise we can use for. Also, this exercise will be very interested about related to how to find distance, how object size, contour, whatever. This all mainly about how handle get the feature and how to handle this feature in image. So for in case of object detection, maybe this and maybe some basic of visual images, maybe mostly will shift to another week because we have 1 week completely about object detection, and even for 1 week is very limit for object detection. Okay, so let's go ahead. So what is computer vision? Probably most of us are carrying around smartphone, and each of our smartphone has 1 or 2 or maybe even 3 camera on it. So I think that on average there are even more camera in the world than there are people. This is some reality. And based on this, as a result of all these sensors, there are a crazy amount of image, massive amount of visual data has been produced out of their devices about from this camera. So I give you one overview on statistic, which is done by Cisco, and it's like I would like to put this in this perspective. For example, in 2015, there are study from Cisco that was estimated that after 2 years would be like, even today we are in 2021, that means this study from about 6 years ago, they expected after 2 years would be roughly about 18% of all the traffic on internet will be which will be about visual data, video, image, whatever, something like this. So that is not even counting all image and all type of visual data on web. Only they expected how much of only the traffic data, only about the traffic. They expected to be 18%, and this is like estimation very high. That mean based on this number of perspective, the majority of bit flying around the internet are actually visual data. And this in reality is very critical. That means we need to find and develop algorithm that can utilize and understand this data. Maybe in real time, maybe in semi-real time. It is how to make our computer is get high level understanding from image and data and receive this image and process this in real time. This was very, very critical nowadays. Maybe if you look about, for example, today, we produce by this lecture, you are listening, we are watching video, we are watching this conference, this like lecture, like the exercise we're doing. Also, we are participant to generate new visual data. So what is computer vision? Computer vision science try to define as the idea is like some concept to understand image and the video and determine what we can computer see, how to and how to recognize, transfer this from like data to information, from something not able to understand to something like have meaning useful, how to pick up some insight or useful insight from this data. In general, we have like 3 levels. we have about our three stages about computer vision. First is like how to get the data, which is like maybe we can get from video, from camera, from other sensor. This is maybe we have video provide like a sequence of image. Maybe we can get other streaming. Maybe we have multi-camera. Maybe we have different type of camera. And after we get this image and convert to digital format, we have to do some processing. After you process this data, you have to get the information. That means we get like some useful information from data. This is like the stage in computer vision. What we have to cover this course, we have to study about how to get this data. I will teach you the mainly one algorithm. Maybe there are another algorithm, and openCV is the main algorithm. Maybe it's wide and popular and common use. Maybe other algorithm I try to let Osama present the basic of it. Maybe it's useful also for simple display image and we can see this in exercise. We need to understand how we handle this image and this video obtained. That means there are a huge amount of algorithm in the processing. Maybe it is hard to cover in a week or months or years. I'll try to cover the main important and the main aspect about this. And after we generate a huge amount of processing, maybe, and they have to consider a lot of aspects in processing. The time you require to process this data, how to do this, the accurate result, how to handle this data to make it like able to understand and organize the pattern from this data. This is a step about understanding. Well, after processing, we get some picture. Maybe then we have to make this picture more understanding, more useful. So this is in general. We try to cover all these stages in computer vision. So what is computer vision field? Maybe even what is image processing, computer graphics, there are a huge number of terminology. So this field of computer vision starts from this, then we can explain what is the difference, what is the meaning. This is field of computer vision is really interdisciplinary field and is touched on many different areas of science and engineering and technology. So it is clearly that computer vision is the center of the universe. But sort of as all the field around computer vision, optics, image processing, natural language processing, robotic and machine learning, whatever, we touch on area like physics, because we need to understand the optic and image formation and how image actually physically formed or created. We need to understand biology and physiology to understand how animal brain physically see and process visual information. We, of course, draw a lot of computer science, mathematics, and engineering, and there are a huge amount. Maybe, as mentioned before, computer vision is the center. So it's not a huge many different areas of science and engineering and technology. And during this many lectures, we can see how it's like we handle many of these topics. So let's see how we see the world. So in general, this is a human how it's looking. We see some image, then our sensor is our eyes, then our brain is like try to understand this and make interpreter to give like estimation about this. And when the science try to develop something, they take the same, try to mimic or to simulate our brain or our human how to see and make this system. So for this, we use camera as our sensor, and this camera take a picture from surrounding, and this camera transfers this digital data as 1 and 0 as bits to computer, and this computer plays the same role about our brain to make some interruption, to provide some information. This is in reality how it's like science try to develop. That means we use try to mimic a human like a sensor to have the same visibility, to have the same understanding. But for a human, it is easy to recognize that is a horse, this is behind is a mountain, and the top there are sky. But the computer see all this information as 1 and 0, as bits. So that means the science should be developed here, a huge of algorithm to provide good understanding about what we see, what the useful feature, what is the insight, how to understand, how to recognize this bit and transfer this from like abstract data to useful information. So why it is this domain hard? Why it is like it is hard to recognize this? Because there are a huge of many reasons. One is the main difficult and challenge in computer vision and image processing is like few point variation or variation. So that means if you take a look from front about this object, if you camera here and take a look with this object, or take it from good angle, or take the top view, or take more large wide camera, focal field of focus maybe it's like higher than that. All this recognize the same object. For a human, it is easy, but for computer and digital system is hard because from him is different byte, different bit, different data. But for our human, it's like completely the same object. We handle the same object, but and the object was recognized is easy for a human, but for computer, it's like totally is different and hard to understand this. Another problem also is camera sensor and lens limitation. For example, this is a camera, you're looking to lower, then if you take some zooming, this is have no meaning. So this is make no understanding. There are many limitations. And maybe from sensor to sensor and some sensors provide high quality also. Some sensor we have some side effect or low quality. That means if you take this area and look about it, this is how it look on computer. Another problem also, lighting problem. For a human, if changes the lighting or modifies the light between, make it easy also to recognize, but for computer also this is make also they make new object, new data, new information. So that means if you This is the object. That means for computer is different object. This is different object because every object have different value, different. But for all of us represent the same object. Another challenge also is the scaling. For example, even for human sometimes it's confusing, but even for computer is like more difficult to understand it. To understand then about distant perspective from camera, to provide the Z value, the depth value, also about the size of object. So if you in camera transfer the 3D information in the world, because we in our information in the world it's 3D, but what we when transfer this, we transfer from 3D perspective to the perspective. That means we lose one dimension. But our brain have some algorithm or some talent to recreate this depth or this again. So always we see our world in 3 dimension. This is our world, X, Y, and Z, which is represented by distance. If you ignore the time aspect or time, the time, this is how is that environment, surrounding environment, how is world. But when you transfer, this is 3D environment, or how is our world. Well, when we handle it, we get like by computer 2D. That means we lose only this value. This completely is we lose this. That means we have only X and Y. But we are lucky our brain is able to reconstruct the depth again. And can you easily, you know that this woman is in front of this boy, and there are this window behind it, and this is, and he is stay over the floor, and this is like, this is, for example, this area is in front of all this. That means, and there are some distance between them. All this information is easy for you. But when you transfer this information in digital format or to computer, we have to provide a very intelligent algorithm to get the new distance. Otherwise, we always understand this like X and Y. Also about the size is like one challenge also. Another important is like a non-rich deformation. Maybe if you have one object, something like this text, this, maybe if you have one object, let's make, sorry. If you have one object, like simple rectangle, let's assume this is something rectangle, and time 0, after some minutes, this is have like some scaling. So for example, now the question, how to transfer this from T0 to Tn or T1, for example? What is that transfer, the translation and the rotation that led this object, because this object is the same, but he doing some transformation and some rotation. This is, even for simple object, is sometimes hard. For a human, it's easy to understand this is the same, but we do some rotation and transformation. But what is, you have like complete image with many objects. What we have to do is how to understand this is represent the same from different form view, from different transformation algorithm. Because we have some problem in geometry, how to process this geometry. Also, we have a problem in inclusion. Even for a human, it's easy to recognize this is the part of this car is behind this box, even the horse and the man between the tree and inside the forest. But if you try to, even sometimes to human, it's hard here. But if for computer and digital system is more complex, he don't able to understand who is behind the object, and we cannot. If you are tasked to detect the object, that we able to detect only this area, and we miss this area. But as human, we able to understand there are some part behind it would be something like this with the same perspective and depth. Also, we have a problem in like different object firation. For example, we have different object representing the bed in different form, in different color, and different shape, and different format, and if different background, even represent the same object. But for us, it is easy, but for digital system, it's so hard. So this is why computer vision is very hard. Even some optical illusion, it is a human to human here, or we are looking about that this is some face or some shape. What do you think? If you looking only the black area, we're looking about human. If you link to white area, you're looking about different shape or part of different shape. Also here is like 2D or 3D or this gap or this what is representing. Even this is 3D object or drawing on the floor. What is this? What is this representation? There are one example. If you have like object detection, maybe I define this, and there are some problem. They are one car, and behind it they draw some many object like bicycle or a human or some car. And if you have system looking about this about computer vision and get this image, what he recognized, this still image is like fighting and behind some maybe bus or another car, but for him he sees there are human here and the car, and if he want to go ahead, this should be the system should be alarm the driver, but in reality this is only one image. So it's really sometimes it's difficult to understand it by computer, but by human it's easy. But what about suppose it's like we have like a big panel. One is like here is one human, and this is some, for example, other object like car, for example. And this is free area, and if you want to go ahead, we can understand this is not the free area, this is a picture. But for car or for any autonomous robotic, they make decision to go ahead, but they hit this panel because he don't understand this is free area. So that means it's really is sometimes a challenge, and especially to many critical applications. But even for this challenge, we are able to generate the science we are profile, very efficient approach, algorithm, method, and we are lucky we have some very power hardware that able to process this visual data and produce and convert this data to useful data. Maybe in early from old time. You can use it like machine learning to recognize the character. We can use like our mobile to do some translation, to get some image and convert this image to text and convert this text from one language to another language. We can detect some license plate and we read it only if the car is go over that limited speed. It's easy for our system nowadays to get the picture for this traffic sign and convert this license plate number and character to something credible. You have nowadays many of application for face detection, adding some filter, Snapchat face filtering. Maybe most of application, most of uh, uh, operating system is running on different mobile, Android, iPhone, Windows, Linux. They have this visibility, and there are a huge number of applications for face recognition and detecting the face of multi-face, whatever. And this is done also in real time. Maybe now we can make a photo and go and search about this photo on Google instead of type the text. Also, we have possibility about this is what we got. This is one approach by Amazon Go and supermarket. So what you're doing, you get only by your mobile, you have QR code, you can scan it, and then you can collect your object you want and take it and go at, and this automatically make the bill and transfer this to your bank account or to your MasterCard and take this amount. This is really is like amazing. This is maybe we can find a huge of similar like technique in like in many supermarkets in many areas. Now it's easy. Another approach is about if maybe in your PC now, and I have now a new workstation. I have new laptop. I shift now. I yesterday started to use it. I can log in by only by face. Even your mobile, you can make log in by your face. That doing some face login, even without your transfer. And even nowadays, our system is very clever. Can for example, it depends about also the algorithm. We can distinguish between image or your face. If you take your image and place in front of camera, some application not don't understand this as your face. They understand this as it's like copy about your image and don't provide you any login. Maybe even if you go to 2012, about 9 years ago around, there are something about so it is like to fix what you are looking. If you are looking and the chance automatically for you. This is the publication done in 2012. Apple first time. This provides some easy attention correction. It's easy nowadays. Another approach. Google Lens, also for example, like you can take any picture resolution. When you look at, you can determine where is the meaning, where is looking, what is the shop, where is location, and maybe have some other information can attach to this image. Another approach is a human shape capture. If you make shape for some human, to make 3D shape, like very accurate 3D shape, you take different image from different perspective, from different angle, and then finally we can create exactly one with 100% the same object. Maybe they are wide using about some effect, especially in movie. Most of our movie depend about some special effect, how to do special effect. Another approach, interactive game. Now most of our game based on some intelligent aspect to produce some interactive between human and the game. Also, this is one successful in computer vision with deep learning or artificial intelligence. Maybe this is now really popular about how to do something like with the view beyond video. How to transfer this from, you take the image from camera and transfer this from 3D from 2D to 3D. Behind this is a huge amount of mathematical. It's mostly is about math or mathematics or an algorithm about matrix, how to handle it, to provide all this transformation from different viewpoint. In medical domain also we have maybe most common in this is autonomous car and robotic, how to allow, maybe it's now hot topic nowadays. Tesla, Opera, Google autonomous car, there are Audi, there are huge of product now. Now they have car they able to drive without interactive with the driver. That means we leave the car and the car can make decision and drive alone. Even there are some accidents, but still with high accuracy. Maybe also autonomous flying robot, like or like drone or like fly. What is hot topic nowadays is like augmented reality and virtual reality. This is wide used. Maybe the new version about Facebook is like with like augmented and virtual reality. How we can interact for our physical environment. In 2019, that's and 17, the vision is used widely in space when we're landing. How to understand, how to collect many images and like stitching this image together, get some one view or panoramic view. Maybe you can do even this with your mobile. We take the same image from different perspective, and then your system matches the image and provide you 3D view or panoramic view. This is generated for you 3D modeling and can be even easy to define what is your position and the obstacle detect. That means nowadays we have many successful story and self-driving car, face detection, search engine, a huge number. This is wide domain nowadays. Why is computer vision and image processing is very important. Now, let's go ahead to in deeply to go in this algorithm to learn how to collect, to implement some simple application, how to understand, how to get the feature from image, from video. So before this, let's go ahead in some definition of the terminology. What is computer vision? What is image processing? Is computer vision is the term about image understanding? Let's give you one example. If you're looking about this image, how many of people you can see here? Who is playing? What is kind of work they are doing? Is there inside or outside environment? If the ball is close or far from them? For example, what about t-shirt? What is the meaning about logo? There are a huge number of things. So image processing is transformation, is some processing transformation are applied on input image, and the output is related is digital image and with some transformation. Example, smoothing, sharpen, construct. This transformation depends about context and issue tried to be solved. But in computer vision, another is like is an image or a video is taken as input, and the goal to understand, including being able to infer something about this. And you have to understand the content. That means computer vision uses image processing algorithm to solve some of its tasks. The main difference between these two aspects or two approaches are the goal, not the method you are using. For example, if you are called to enhance an image for using later, then this is maybe called image processing. If you are called to emulate human vision, like object recognition, object detection, defect detection, automatic driving, then it is maybe called computer vision. Because this question, I always get this question, what is the difference between image processing and computer vision? So I try to provide you the meaning and what is useful to understand it. Also, there are different aspects about computer vision and computer graphics. In computer graphic, we create a realistic image based on mathematical model. That means I have digital, word, computer, another aspect, whatever, and maybe I have this, and based on this, I able to produce some image and interactive with image. This is what is called computer graphics. That means I create some image, realistic image based on a mathematical approach or model. This is our base to create image. Another way or opposite direction in computer vision, create from image, I try to find the pattern. That means I have to find mathematical model from real image. Okay. Now, let's go ahead. What is image? How does our computer see the image? Image is represented as 2D array. We have intensity value in case at the only one grayscale. That means you have only one color, white and the black, and with that change in value between this gradient between black and white. That means if you have only image, let's take simple approach. We have only it's like black image. That means that this image have 2D array. Like this have x-axis and y-axis, and the value for each area is changing between two values, between 0 what is represented is like a black, and the white value is between 2555. That means if you are complete black area, that means your value is 0. If this area is complete white, for example, or this region is completely 255. If something between it, that means the color change. If it's 100, for example, that means somehow gray, not as black. The color image have three, maybe common approach is RGB. That means we have 3 layers. I will explain later about what the meaning for 3 layers. We have also some resolution about this is defined number of row and column. That means we not call about x-axis and y-axis. We talk about this is like column and some row. And based on this number, we get the resolution. Not sorry, some kind of resolution also, because we have also number of pixels inside this frame. But in general, this is the resolution is defined by multiply number of row by multiply by number of column. It's the x-axis by y-axis. Now we're not using this. We represent x-axis by row. By y, and that means y is like representing the row, and the column is represented by x-axis. For example, let's take to make more clear for us. If you take image like 20 by multiply by 20, that means you have 20 row by 20. I'm just making 20 column. So, and every column have like value between 0 and 25. That means if it is like 0, here I make this black. What I doing here, I don't make this black. I make from my approach. I will represent this the white area by 0 and give the black with some value. I infer the representation in this approach. Maybe I do here some normalization if you want. Because if you remember the teacher normalization, when I change the value between 0 and 1, that means I transfer this range to this range. There's some many algorithms doing something like this. So if you want to consider this example, can you tell me how dark is a pixel should be representing as a value between 0 and 1 if you take this normalization? If you consider this the white is represented by 0 and the black here represented by 1. This is represented by 1 and this is area represented by 0. So what I do here, some normalization. So normal image have like value between 0 and 25. This range can be some representing or compute can store in like 8-bit. This is why it's this number how is take it. But if you define this is like about 25, we get like normalized value between 0 and 1. This is some approach which mainly sometimes or widely used to do some normalization about image. Maybe reduce computation, maybe we have different, even sometimes we are using the same value. But this is maybe some provide some provide some clear overview about how the image is look and once do some normalization how it's look. This is Islam. If you take like a gray image. That means image with only with two color. What's the situation if you have like color image? If I have image, this color is like normal image. This image can be represented by three colors: RGB, red, green, blue. Every color, every channel can provide the same height and width, the same. That means everyone have the value also of every pixel between 0 to 155. Every pixel. That means I have the image with three dimensions. That means I have like first dimension is like this is like about white. This is high. And we have depth of this is like three channels. That means I have three. First image, maybe if you take this is R, then we have green, then this is blue. If you mix this of all of this, we can get an image. Also, every image has each color. Sorry. Yeah, because this is image. This is color channel. If color channel will have intensity value, that means every pixel can be represented as intensity value. That means this intensity value is like between 0 and 255. Even the same. So if you get to represent this as image, this is like it is somehow similar to grayscale image. This is try to represent the color channel by its intensity between 0 or 5. They determine how red color in this pixel, how green color in this pixel. If this is strong color green, that means you have high value for green. If this is somehow less green, that is like more to be black. That means the high number is how much we get like red, how much we get the green, how much we get blue, and the mix between this we get the real color or the true color. Keep in your mind also, this is important hint. Your computer don't know anything about that this channel is red or this is like blue or green. Only he understands there are three intensity channels, something like how it's like this. Three matrix. He always understands this is with this value as matrix, yeah. And this is value here. The same situation here. He don't understand this is blue or green. He understands this is matrix with some value. This value represents the intensity of this channel. So let's make complete example. We have like image. For example, we have image with like height and width. That means our height is like 1208. This is represent the row, and there are some width with 720 represents the width or column. And we have the three channel. That means this is like represented by X, Y, and these steps. We have channel 1, channel 2, channel 3. This is from all or common approach to represent the image. But in reality, this also maybe I will explain this in one real example. What is the difference about color? There are other alternative color mapping. Now we understand that the image will be grayscale. That means we have one channel. That means we have white and black only. That means only one channel. And we have possibilities that the image have three channels, which is common as we know, but in reality there are alternative approach. This is what is called RGB color map, what is described. There are another approaches like HSV, hue, saturation, and value about brightness. Also another approach is HSV about it. This is based on changing this maybe represent. So even if you try to change like the color map, you can do a lot of application. This is how we can get different approach. For example, an RGB image is this representation have a problem about line, about the brightness, and B, it is easy for hue saturation or value, or hue saturation of also lightness. But in other approach, this is not linear and not uniform. Maybe it's not complete this word. So RGB image enable as a color as R is red, green, and blue. It is adaptive color model. We can assume that each of this channel is given by the value between 0 or 1, or to make the value is normalized value with 0 1, but we can be using encoding this value between 0 and 255. HSV enable or encode the color as hue, saturation, and value. Here we can assume that the hue is the value between 0 and 360 degree a circle. We're looking about this. This is about the hue. Here we're looking about circle, and this circle between 0 and if you go on round, that means the next one is 360. And also both saturation and the value, this is saturation and this is value, is between 0 and 1. Based on changing this value, we can change the color. So if you're interested to go how to encode an alternative color mapping and what's the benefit, maybe please identify for you many approaches. And even that means this color can be represented by RGB color mode or mapping encoding, or USV also. There are, I want to not forget, there are other image format. That means other image encoding. Maybe you are, if you add some alpha channel, for example, if you encase PNG, if you get like RGB color, that means you have color image, red, green, blue. We can add extra channel as alpha. Know how it's like transparent this. Maybe we can add another layer as a distance, which is depth. You imagine how to go deeply, but this is increase the effort in computation and effort to get a real feature or like a real information in real time. That increase the computation time and increase the complexity. Maybe GIF also, this is some animated image. We have 2 or 3 images. Maybe it's about how size of image. Maybe GIF is like representing not by vector, by vector. This is about image. How maybe also let's go about video. Video in general is as like sequence about image or sequence of still image. Still image is one image, but if you have image that's changing over time, that means we have like a sequence or streaming. That means we change this image, this pixel in this time, for example, this intensity of pixel was maybe 100, for example. Then after 1 second, maybe changing to 50. That means this changing of intensity make some meaning, and this our human can understand some movement. There are something about this video is representing about sequence and frame. That means the image now not called still image, it's called the frame, and something like about how much frame per second. So to make clear approach, we have like image, still image representing as like 2D, like I have a function mapping between the height and width, between row and column, and this image can be have different channel, and every bit of color can be represented with every pixel can be represented with 1 byte, because that means if you want to represent 1 pixel here, we need about 3 bytes. So how many different colors can be represented? That means 2 power 24 for representing 1 bit. If you have 3 channels, that means this number 200 power of 3, that I guess is about 60 million 70 something like this, 216 I guess. This is if you represent only in this situation. And video, we add to this function as a parameter. We lose the distance. Always in this, if you want to add the distance, we are losing. But here we add another aspect is the time. That means we have still image, which is represent a frame, which is changing over time. That means this pixel value change always over this time. So the question is for you, what is the duration in 1 second if you take the frequency, take a frame of what 13 hertz? You can figure out. This is how it's like going to represent the image and the video. For a frequency, if you take 13 hertz, in general can be represented as 0.0333 and go up, because that means we have 13 cycle per 1 second. Let me clear this. We have like 13 cycle per 1 second. So now, yes, 13 cycle. Yes, thank you, Christian. Now the question again, how to handle the maze, because now we have to understand how we represent the image, the video, what does it look like, because if you understand how to get the representation, we can understand clearly how can handle this with algorithm? How can I understand algorithm clearly? One famous approach is like, and the library and framework that handle image is like openCV. openCV or open source computer vision library is library of a programming function mainly aimed at real-time computer vision, and computer vision just mean using computer to analyze the image and video, because video is like sequence of image, and the goal is to provide an approach is similar to the way or the aspect that a human analyze something. So this is actually created back to 1999. It's by Intel, and it was written by C++ and still written in C++, but we are lucky is some versions now is applied by Python and C and Java. If you would like to work in Java, we are trying to use this and mostly using like a course based on Python. And as I want to mention that thus we can most as if you go on internet, maybe we can find a huge tutorial in C++. The same algorithm is implemented in C++. I have the same wrapper implementation in Python, for example. The last version is 4.52. There are different type of version on 3.4.114. And if you want to go, there are a lot of documentation and the website on openCV. We can find many of algorithm is implemented in Python, Java, and C++. The mostly the dominate documentation mostly in C++ and Python. And C++ will be faster because it's close to hardware. Somehow is slower than C++ if you're using Python, because the Python is interrupting language, not compiler language. The both C++ and Python is open source. If you want to install this library, you have different approach. Maybe you can compile. You have the source code, we have to compile it. That in general is not easy. But we are lucky. If you want, we can use only pre-blend library, which is easy to install. Okay. What is the main package in this? We have maybe because when you install this openCV libraries, there are different packages. If you install only the main model, the main library, the main package, that means you need only openCV Python. If you want to include this with model and other functionality, that means we have to use openCV control Python. If you need to do something on server or some limitation, only not GUI functionality, or you have to use a lot of focus on only the core. Maybe we can use openCV Python headless. The same situation. There are no functionality for graphic user interface. Maybe we can use it. But my recommendation: don't install different packages in the same environment. You have always I found this problem always. We have a lot of like problem if you install different packages in the same environment or install different version of openCV. This is like what is recommended. If you want to work only on the main module, this is useful. And if you want to work with functions, this is useful. I recommend it always for easy to reduce a lot of effort on. You can use only openCV control Python, but take in your consideration when you work, use one. If you understand you are not working with GUI, this is more useful for you. But if you want to use some GUI functionality, this should be considered this both. If you have the main or if you have the main with function, but don't install multiple different packages. Maybe they work fine in general, but a huge impact will be faced when you handle it. Also, to give you overview why it's focused on OpenCV. This is why library is used in many domain by Google, by Microsoft, by Intel, by Nvidia. When you work in like deep learning, by Sony, by Toyota, by all mostly big player company, openCV most dominated library for handling image and processing. There are, by the way, there are many other library, but openCV one dominated library or common use library, and have a huge built-in algorithm that implement by openCV. Now, let's go ahead. How to install this library? If you need the main model, we can use pip install. Did you remember? If you remember, I recommended for you the. Need to check if it's able to open new. Okay. If you go to pip install yes. So this is like the common manager. We can install many of library on model. We look about this when you install ASCII-Learn. We look about when you install different algorithm, Panda, Matplotlib library, whatever, and by. Then, if you want to go, just write it, and we can find a huge what is the main installation package and explain the different option and how to onboard, and we can find a huge. If you go also to openCV, official website, we can find a lot of tutorial, a lot of courses also. If you're interested, we can go to show all these courses. Maybe there are a huge. I recommend it to look about these courses. This provides you a wide learning. Maybe also there are some tutorials, some blog. Even if you go and if you go to some documentation also. Maybe if you let's go and like maybe tutorial here. We can find a lot of example. For example, this is provide you introduction, installation, how to do if you want to build a different operating system. Maybe if some image processing, maybe this give you example and give you, as you mentioned before, 3 implementation. We can see in Java and C++, and we can know exactly what is the version. That means like at least should be higher than 3.0. That means there are huge possibility of tutorial, and here we can select what we want with this version we are looking about it. I don't prefer to go in the last version for many reasons, because some bugs still happen. Maybe to more stable version, maybe 4.50 or 0.4. For me, it's like I was using like 4.01 now, but sometimes I need higher, but mostly it's good for you. And this is provide you a huge about possibility and a lot of description with tutorial. Is really well documented the library, and even there we can find a huge of YouTube channel to support you. I recommend you to go on this website and use it mainly for your code documentation. And there are also examples for any approach, any algorithm. So we have a huge of algorithms that implement in openCV. Okay. So for installation, we use like openCV. If you need the main model, I recommended this, and I recommended this also. That means I define and your command line build install openCV control and specific library, specific version. One recommendation, not go to last version. I use, for example, 1.0. Let me check what is one I use it. Okay. Okay, maybe is okay. Now we are run Python inside it. Then if I make import like here, like CSV2, that means the library is included. Then if I print like normal cv2 slash version, this is what as library I used. Maybe if you use like paper freeze, maybe you can get less of all the package, but I need to show you only only Python. Okay, that means I using like 4.1.0. Even for you, I recommended to check the higher version. You can have different approach. Maybe I recommended to use like 4.50. Also, if you go in openCV, we have some release, some debugged version that is like something about this. Maybe there are something still under developing, something with developer, some bugs, something is like more stable. I recommend to go with 4.40. Maybe I guess this is like only the most common, like 4.40. 4.20, 4.10 also. This is most is like common to use. In my case, in my application, maybe in your application, maybe you need more. If you have some new feature we interested, we can use higher version. Okay. Now, how to import image? By the way, we get some practice by Osama, maybe today or tomorrow, because we have to discuss also an exercise another approach library, but in basic, but we have to focus more in more complex scenario. Maybe in object detection, we have complete using object detection OpenCV plus some functionality from deep learning. Also for the data augmentation, we have to use some algorithm from image. So it is good to extend the basic here. So If you want to create a model that is read the image from our computer and display it, we have to, this is only we need 4 line of code. Compare if you do this in C++ or another approach, you need a huge line, not too much for simple, because openCV reduce amount of effort for you. Let's go ahead in this code and discuss in detail step by step. What we have something, this line for importing package, importing the library. Maybe if you're looking, sometimes we can use alias as CV if you want. Then we have to read the paths, and then we have to show them in window, and then we have to wait. This code used to import an image and display this image with this window. Window is naming out window. And then we have to wait until the user keyboard to input to terminate this application. This is how. Let's go ahead line by line. So the first line is easy. It's only import the version of openCV package. Sorry, import the package of openCV, the library we are installed, the specific library. Then let's go and like image read, mread. We have here 2 arguments. The first argument is the file name. One common problem is we are always, I found it, my experience when teaching, especially in computer vision, most of students or most of people make mistake in this. Sometimes if you write this image in different paths, that means we get not able to access, that means you get your error here. That means here should be exactly the path where image is located. That means this file name with complete path. That means if you are code in the same folder, same directory, you will not need to write the path. But if it's like higher library, maybe I make like data as folder. Then I make my image here. Maybe this. Maybe sometimes I define one variable as the path. Maybe I get from operating system package, and then include the complete path. Also, we have another attribute here. This is determine if there are color image or grayscale. If you're using like one, maybe I using color image, maybe I can explain, we can look about this even in documentation. If you go here, maybe I try to use CV to MV. So this in C++, maybe this, yes. This is like class CV search here. Okay. So this is like in C++, is Python using like mread and this file name and this flag, and here we can read exactly which flag can be taken. So if you take an image, we have a huge flag. Maybe if it's like in Python, what is in C++ with it, and maybe sometimes it includes some example, I guess. If you go back, maybe you can find some example here. This is in C++. Maybe if I go, there are unfortunately only in C++ now, but there are many examples you can find in Python. Okay, this is describe exactly what is like. Maybe here we can, this is most example as you mentioned before, most in C++, but Python we can find also too much. And at least I explain what is like read what is the flag parameter we need to use. So that means the second parameter always about determine if you use 3 channel, 1 channel, 4 channel, if you was transparency or whatever. Maybe if you use a minus, that means you are using color plus the alpha channel, the transparent channel. Okay, this is how it's like. We can use like function and read. If you take read is the image and make is 1, we get like color image. If you read is 0, we take like with black. Also the same situation. This function ensure you have like string value. This is the name of window this is the name of window you can see here. And this is the image want to display. Take in your consideration this, if you can define another argument to make like different image size, but this, if you don't make this, is fit automatically to image size. We can use another library method to make some display also for image, by the way. And last function is like wait key. What we're doing, that means here we have to give value. This is what is retained this function. Retain ASCII value. That means the key when you press in keyboard, and this is using to determine how much of waiting second after press this key. And based on this, I can determine to terminate our application or to do something or still display the image. And this is counting in milliseconds. So if we need to do some image processing, in general, we have always to do, this is somehow our embed. We have to import our package, read it, then have something to display. We have to define the output string, and this is the image after this, and then we have to do some waiting to display this to use. Here, we should be to our image processing. This is what's explained later by Osama. Maybe tomorrow, maybe some basic today, maybe tomorrow we go ahead with Osama and this. If you print the image, you read the image. Now the image is stored in this variable with an img. Now, if you want to print, this is that we show you that image. Sorry, it's like image is representing a num-dimension array as num-by array, some 2D array or multi-dimension array. So that there are wide or some strong relation between NumPy and openCV. Mostly in your approach, even in deep learning, NumPy is the one is good library, is wide with it, especially my library, especially with openCV. Let's make this example. If you take image, we read image and print this image and print this type of image. So this is a grayscale. That means we have one channel, and this is displayed as array of this value. That means this 22 is like representing the value of image, how it should be. The pixel intensity value, which should be between 0 and 255. If you print, okay, sorry, maybe this I recommend to test you with print color, and maybe this is how it's looking. One mention I want to mention, maybe I will discuss it later, about RGB color when you print it. This is if try to check it if you print this with RGB color. Maybe we get multi-dimensional array. Maybe you have different arrays. Try to test this by one. What is VR out to understand how it's like different one, different array, different channel. If channel represented by NumPy array. One approach I want to mention, an openCV using VR, as you mentioned, there are some color standard is called RGB, but openCV using color like this is like the value. If you take like all this channel is 0, 0, that means you get completely color. If you get like only the green 255, you get like green color. If you get like the blue, only this full color and the rest is 0, then you get blue color. This is a standard, it's called color matte RGB. But openCV using the same approach but in other order. That means using like BGR. They switch between red and blue. The reason why every developer at openCV choose BGR color format is a probability back to BGR color format was popular among camera manufacturers. This is wide used in camera manufacturer and software provider. Example, in Windows, when you specify the color value using color ref, they use BGR format as X00. If you read it one time, it's like X OX is like 1.6. Then 0, for example, 00 B G. Maybe we can read one time this RR. This is BBGGRR, for example. BGR was chosen is made by for historical reason, and now we have to live with it. In other words, BGR is somehow is some reorganization about this. That means when you raise the camera, the image, and rate, they provide you something like this. If you want to make some processes, take your example. This is the standard is RGB, but when we read, makes this is the first matrix is like blue, then green, and red. Okay. Also, I want to mention another point about coordinate system. When you go in any image, as we understand, this is the origin point. This is 0 by 0. Sorry. This is the organ. That means this is the 0 by 0, and this is the x-axis represents the column, and that means represents the y, and this is the y-axis represents the height, and represents the row. And this is the origin point. If you want to determine this pixel, in general, in math, we know this is something like this. This x and this y. By image coordinate, this is like the origin is shifting from down to up here. Okay, this is like we have 0, 1, 2, 3. That means we have something like this 3, 4, for example, if you want. Maybe this is like in y. Maybe he has not correct. 0, 1, 2, 3, 4. Okay. This is 7, 0. This is like 0, 4. This is how we get the coordinate system. Okay. If you want to look camera to read image with not like to only select specific color. That means, as you mentioned before here, why I asked you to do some the task to do some coloring, because we know this is three and number array. That means if you want to go with red, we take the mixed slicing and only take all this value and assign to 0. All this matrix was represented by red here is assigned by 0. The same situation with green and leave below as it. We don't assign any value. Then we do some image show. We can see the same as we see here. This is for red. For blue, that means I make the red and green is equal to 0. And if you want to red, I make the green and blue to 0. If you need blue, I make the red and blue as 0. By Osama, I don't want to go ahead. Maybe Osama will explain the blurring image, how to do blurring, maybe how to, and some basic image with openCV, how to draw some basic shape, how to draw many aspects. Maybe even I try to cover all this aspect and the algorithm behind it and theoretical background, and will differ for you some example. And by Osama will go in detail in many image processing based on this. This is for today. Thank you a lot for your attending. Now, if you have any question, I am happy to answer this. Okay?
Recording stopped.
This is why I explain. Now we understand what is computer vision, what image processing, what is a computer graphic, and then we are dominate to use openCV as a core for our processing image. We have different aspects. We have in this week to study the basic, the fundamental, some feature. Maybe later in coming week we have some week for feature facial recognition that we have used widely openCV. We have some 1 week for image processing for object detection. We have wide week. So in this week, mainly I focus on openCV, the concept and how to use many algorithm. Maybe I try to in last day. Maybe I explain about camera format and the math behind the camera model, because it's mostly if you understand the math and behind it, you can understand many or develop many wide applications based on your obtained image from camera. Because what we're doing, we convert everything's matrix and doing some multiplication on matrix to get different format about looking. Maybe if you want to understand top of view camera, maybe I will share screen. Maybe sometime if you go in automotive, we have something like car, and we have camera in car. Maybe there are two camera here, inside view and mirror, and we have like camera behind it. But when you go to navigation system, we show the camera from top, like 3D environment, and we can change this camera. The camera is something like this. We're looking about camera from top. It's called top view camera or bird view camera. And if you are in a modern car or more luxury car, you can use this camera to, if you move this and touch screen, we can show in any direction. But in general, what we have in reality, we have four camera. We have four camera. This is some that mean what is doing our operators. Take the image from this camera, plus this image from this camera, from this image from this camera, plus this image from this camera, and matching this together. That means this camera produces some view. This camera is something like view. This camera is something like view, and this is some camera like some view from behind camera. This different view is matching or structured together to provide top view camera. So that means the system understands 360-degree of freedom of looking up around this car. This is why. That means we have to understand the maths and mathematical model behind the camera. Okay? This is my, maybe I try to focus on the last day, maybe, and try to discuss something about. Okay? Any question? Any comment related to the lecture? In case no question, now around now 10:20, we take 13 minutes, about 11:50, then we shift to Osama. Yes, it is really, thank Oliver, thank you, you. Sorry for this pronouncing. Yeah, it's very interesting topic for me. I am very excited to offer this many times. As I worked with this domain for 5 or 6 years and deeply. It's like wide interested domain. We need an object detection, facial detection, and deep learning. Most application deep learning nowadays is the core of this is image understand. Only you have to take in if you understand this aspect and really idea is like we have only something like 3 issue we have to take in your consideration. You have this, you have part to get image. Maybe you can some improvement how to get image in real time. You have some understand, some processing for this image. This just means you have to get the useful picture. Then you do some understand. Based on these phases, we can create a huge amount of application. Even we can improve this amount of application, but still under development till now. Okay, now I don't want to waste your time. If there are no question, we have to shift to break to 10:15. Then Osama will provide very interesting issue with his exercise. Okay.
Hello, sir.
Hello.
I would like to know if you take like some picture from our phones. So how do you proceed for those stage like acquisition processing? If you can, is it there is a way you can do labeling in order to be understood by the in those process in order to proceed in those process.
Yes. Okay. This is what we will do. So if you take image from mobile, this openCV provide the possibility. Maybe I don't experience this like it's like you get not only from hard but from the hard disk, even from sensors. There are some of that. Some openCV, some version that is planned to install even to iPhone, to any this is able to read on iOS and Windows and Linux, whatever. So what is this doing? This as interface. Based on this interface, I can read from this board from camera, and there are maybe some maybe I try to explain in object detection. Maybe I do tomorrow, and maybe I deliver some hint. Maybe there are one book describes this in detail. Maybe I can announce tomorrow. I will take concrete book. So, because here we have take image. If you have one camera, if you have two camera, if you have three camera, if you have to synchronize the same interface, how you get the same image with the same time stamp. Then we take this image as a digital format. What we're doing later, we apply some processing. And in processing, what we're doing, we collect some feature, we're doing some enhancement. Then this feature, if you use it later, we can get some good understand, some meaning. For example, if I take from, I make a simple example. Take one image from camera, only take it. and then I do change the color map between red, between RGB or SV. Maybe I do some segmentation. I split the background from front end. Maybe this is what is using even sorry. Maybe here in maybe if I make like something like this, if I try to download virtual background, maybe now in my camera, we are looking about me and we see my background, now if I try to upload this, we see how is this some filter, only they doing. They take image and make some only define image from image and do some background, and even it's easy, he now detect. Even in 2012, there are example, if you're looking about the camera, like my eyes is over, and then it become easy for first time to recognize the eye easily and to recognize the shape, where are you looking. Even you can add some different filter. Maybe I can add some image. I hope still I have some image in my scope. Let me check. I have some image. I hope still I have some image. So I can change even the background. Even in your, it is depend about platform. We can do what we do only. We get the onboard. If, for example, in worst case, if you have maybe not operating system like your iPhone or your Android, if you have specific application operating system not need able to use this camera, what we have to do, we have to make library or rubber to get the onboard and format this to openCV. So it's like wide area we can use like openCV, and even in simple application, in Skype, in Zoom, in real and daily life using widely openCV. And maybe what we're doing in this week mainly about understand how to implement the basic about this. That means we understand how to get the image from different resource, from camera, from hard disk. If you have two cameras, how to do this. If you have to switch sometime between camera or video, or how to read directly from desktop. And then we apply processing. Later we do based on this processing, we do a lot of maybe exciting technique. Object detection, detect the face and recognize if you are smiling, about your emotion, where you are looking. Maybe the admin by Mercedes-Benz, I tell you something. They do integrate some deep learning, some physiological aspect with image processing with many. They provide some advertising about new series about Mercedes. Then there are screen, and there's on screen there are camera, and they are looking about where are you looking, in which part of your this movie. Maybe some people interested in the price, maybe in something in color, maybe in background, and based on this they can provide some estimation where are you looking, and then they get also your impression if you like it or not. If you found, for example, the price you are choosing or not. That means we touch multi-area, from physical, by psychological, by mathematics, by a huge amount of area. Okay, unfortunately, computer vision is wide domain. So I try to deliver most basic and how to use it, and maybe I try to deliver some aspect we can handle it. But if you go deeply, we have to read in detail a lot of maths, and then based on this, we have to understand a lot of aspects. Because there are always for camera, there are different type of camera. You have pinhole camera, you have fish hole camera. Sometimes you show the camera is like the curve, sometimes camera is like flat, like webcam camera. These are different angle view. Some wide camera. If you're looking about, even you can find some camera is really wide. We have very close area, but can able to show like long distance. But the camera wide area can show. For example, in my laptop camera, maybe it's about 120-degree field of view. But in my Mac or PC, it's like I guess more narrow. I guess. No, it's the Mac is more wide because you can see the wall of my room. Okay, I will do my best to make a more interesting or more useful aspect, maybe. And Osama will support me, and maybe he prepared a good presentation we discussed yesterday and over yesterday about the detail, and we can go with some. At least you have to understand how first how to represent image, how to handle image as number, because computer not seeing the image as you understand. This is the main challenge: how to understand the main aspect as computer, as digital system understand the image. Then based on this, we can build a huge application, and we can understand clearly the problem to deliver or to improve your algorithm to provide more reliable and useful information on result. Okay.
Okay.
So if there are no other questions, thank you, Christian, for your comment and feedback. And maybe now we can jump to break, and after break we go with Osama in detail. Okay?
We'll jump to the break. I understand.
Okay.
Thank you.
Thank you for your all support. Okay. So let's go ahead and break. Now I am interested. We are about 15 member now around. And with me around 16. So let's go with Osama after break, and I will be stay in background, and we can have some discussion during exercise. Okay. So it's time for coffee again. So take your time and join in break. Bye.
No coffee. And no coffee.
Hello guys. I hope everyone is back from the break, and I hope you had a great weekend. So, we are going to start from image processing basics from today to get an idea. If everyone is back, maybe I think we are 15 participants now. So, we should start maybe.
Bom wiki.
Okay, perfect. That's perfect. Imaging library by using the pillow library as well, by opening it and manipulating it and saving many different images by making several copies of it. And you will find a lot of examples in that link as well in the pillow related to the pillow library. Now, just give me a second. Okay, it is very easier to install, and it supports Python 3, and it has active development. And why see in the picture as well, it is just an example to show you that, as we have discussed about the convolution last week, that convolution is just multiplication or any function with the other matrix to get a separate result. So we can, by using this concept, we can perform a lot of functions, and we can apply multiple filters available in the pillow library. And then we can extract image from in animated gifs, extract images, metadata, and draw a lot of further boxes from the images and separately as well. So there are a number of functions available in the pillow. So that is the basic setup. I mean, you can find the documentation here, and then if you are currently working on the maybe if PyCharm, then or you can directly install it by pip install pillow, and there would be further links in order to find the basics or the examples or the list of modules offered by the pillow library with its documentation to get the in-depth knowledge of different functions. So let's start from the basic program. Like for example, as you can see, it is just a picture, and from pill import image, and image is equal to image.openBird.jpg, and then I can show it by image im.show. It is the im is equal to image.open, so im.show will gonna open this image, and then I can print number of different things here, like the bird image, what is its format, what is its image size, and then image mode. So in that particular case, there is output would be like it's that is the file, and the format is JPEG, and the current format of that would be 400 into 400 is the image size, and then mode, as you can see, it's the RGB, 3 channels. So it would be a color picture, and it will show you the RGB. So that is the basic reading image file by using the pill library. So again, now the here is the so some functions, simple functions. Like firstly, you can resize it like 128 cross 128, as you can see in the first line. So previously, if I see, so the size was 400 cross 400 of the real or original image, but I can resize it, then I can rotate it. After rotating it, it would be, its angle would be changed. And then maybe what I have done here is, I in the picture, as you can see here, it is the transpose, flip left right. So that was the original picture, and when I flip it, so it would be changed in its directions. So then I can do it with the flip top bottom as well. This is the top bottom, and then you can do the flip left right as well. And then you can rotate on multiple angles of 45, 90, 180, whatever the requirements in your specific project is. You can perform a lot of functions there. We will gonna put it in the exercise as well on Jupyter. So again, now you can crop the specific portion of the picture as well, like the box is equal to 100, 100, 400, 400. What are these values? So left, upper, right, and lower. From left side, from where should you want to, start cropping it, and then what should be the upper value, what should be the right value, and then you will have a specific box of the image, and maybe you can
Recording in
if
progress.
if you want to see a specific portion and the other portion is not required by you, so you can maybe crop the picture and remove the original one, and then you can perform whatever is your requirement, so you can crop it as well. And then there are similar functions like you can transpose it, you can paste whatever the region, like as we have discussed in the previous image, that you can get that box of the image, and then that region can be pasted back to the original image as well. I mean, it would be on top of that picture. And then when you will be putting that region on the top of the original image, also you can what perform here is image.rotate 180 degree. Maybe what you have cropped was the box at the 0 degrees, and when you want to paste it on the real image, you can rotate it as well. So these are the just the examples, not the, to give you an idea that how many different functions you can perform, and maybe in some cases you want to perform that as well, but it's just an example to show you that maybe you can rotate as well, and then you can paste back the box on the real image by cropping it. So again, here there are a number of filters available in the pillar library, and for that you can maybe unsharp mask, and then you can set the values of the parameters like the radius, like the percentage, threshold, and then further on, whatever you can set the value of a radius, what is the size of the area, and then the percentage of contrast means the illumination or more better quality of the picture, and then the threshold, which is minimum brightness change needed before filter takes effect, and then there is a kernel size, and so on. Let's see an example from the filter. So let's say this was the input image, as you can see in the top left box. And then if you want to perform the unsharp function here with the radius 2, so radius would be the area. So that specific result would be according to the 2, and till you will be increasing the size of the radius, so there would be different results regarding that. So we're gonna see an example of blurring as well in that particular case. As so so here it is the blur, not the contour. We're gonna see the contour as well from fill library, image, and then maybe image filter, and from the same library. And when I apply here filter, and which specific filter I'm applying here is blur. So as you can see in that picture, it is not the original image. The original image was clean and clear, that it was a bird. But when you will apply a blur, and then you can apply Gaussian blur as well at different radius as well, and then you can maybe perform a lot of filters like the blur, detail, edge enhance, emboss, find edges. So that would be a great exercise for you to get the results of applying those filters on different kinds of images. So again, here, as you can see, we can, okay, most of you, if you have a concept of contour, what is contour? Contour basically, and if you have an object, like in a previous example, there was a bird, okay, that is the different one. So in the, yeah, maybe, yeah. So here is the bird, and as you can see, there is a unique shape of the bird. And if you want to just see the every design of that, or in terms of image processing, if you see it like a shape, what is the shape of that specific bird, so you can use contour. And as you can see now, so it will give you a maybe outline of the specific bird. So for that purpose, you will gonna see the contour. And also in the we will gonna see it in the openCV library as well, that when we want to find the objects, like for example, if we have 5 to 6 objects placed on the table, like the ball, mobile, or the mouse, cup, and when we want to find the contour, then we would be aware about the shape of the object, and then we can perform a lot of functions, like what if the shape is that, what is the center of that shape. Then further on, we can measure the size of that object as well, and then on based of those contours, we can find the distance between two objects as well, and so on. And also, if we further talk about the contour, then we can perform it with the radar cameras as well, because as currently, if we would be doing it with the webcam, and somehow if we have radar camera, so in that there would be a concept of a laser sensor as well, and from that perspective you can get the depth very easily. And then you will be aware that, okay, at the maybe 4.5-meter distance, I just want to see the object. So in the 4.5 meters, and I gave the range of 5 meter, 4.5 to 5 meter, just at that area I want to find the contour. So all the other objects maybe would be ignored, and add that specific. So it's a useful concept of contour if you will be working on the different projects later on maybe. So you will gonna deal with it. So again, there is a concept of watermarks as well. What is basically a watermark is when, as you've heard about it, that when a photographer shoots different kinds of photos, he puts his name on the image, so it should be not used by any other person by his name. So most of the time it is used by them as well, like Adam's photography, or things like that. So you can, by on the image, on you, by your requirement, you can put a lot of things on the image, like the text, like the boxes, like the some new graphics. So it's a very good example of watermarks in terms of photography. So we will gonna see an example of that as well. Like first of all, we will gonna have an image, and then we want to draw something on it. And if we would be drawing with the text, like for example photographer, or any company's name there, so we can set the font as well. And further on, we will gonna see an example of it. And now, processing individual bands. So as you are familiar with the RGB images, so in the black and white images, and then there are RGB images and gray images as well. In the RGB image, you will have 3 channels: green, usually it is like RGB, but yeah, I need to know as well, like why the OpenCV it is called as BGR. But yeah, definitely the meanings are same: red, green, and blue. And by using the pill library, you can identify in every single band separately. Like for example, if you have an image, Now, okay, we will gonna see an example. So for the syntax area, as you can see, dot image dot band image object, and you can perform it by that as well in that function. And then there would be parameters, and in the return value, whatever you have set below that, maybe R or G would be equal to 0. And on the blue side, you want to just see the picture, or you are required to get just a picture with the blue color. So you can extract it by using by processing individual bands. So in this example, as you can see, we're gonna see it in the Jupiter as well. So that was the real in the, not the in that particular case, as you can see, only the red color is there, and all the other colors are we have removed those. So import image view, we can use that library as well to read the image and to write the image as well. So if we read the image, and that is the same image what we have seen before, and then what I'm doing here is I am writing red image, and here what I am identifying there is 0. 0 is showing you the red color, 1 is showing you the green color, and 2 is showing you the blue color. So 0, 1, 2, 3 channels we have differentiated here. Now if now in that particular case, that red image is I mean identified as 0 here, and the other one are blue and green. But that red JPG will also give you some colors of green and blue, as well as we have not set the values of those colors in that picture. So again, if I want to make a pure red color image and remove and set the value of other colors equal to 0. So let's say here, if I am I just want a picture with the red color. After that, and so red image is equal to image.copy. We can copy the image, and then red image 1 is equal to 0, which is green, as you can see here. And then the red image 2 is also equal to 0. What remaining values would be there? That was the default, and it was red. So all the other values from the 3 channels, 2 of them are 0, and then we can write the image like red image.jpg, and then red image we're setting from here. So in that particular writing an image, this would be the particular image that we can see in the individual band of red color. But we will gonna see it in the example as well. Maybe we can perform it with blue color. Then you can enhance the image as well. I mean, by giving more luminous quality, or you can say sharpness in the image. So as in the current example, as you can see from the library, you can import image enhance, and then some variables equal to image enhance dot contrast im is the image what you are reading before as well. And then enhance 1.3, which is a 30% more contrast. Whatever the values before those were 30% would more be added in the same example to see the better quality of the image, or maybe it would be more brighter, or it would be more luminous. So now this is another example. It is just to show you that you can draw a specific box as well of your choice, of your color. Maybe you, if you want to hide something in the image, and you can put a box there, or maybe if you want to get a specific box from the picture and then paste it again. Maybe you want to hide something. There can be multiple reasons. So for that, you can maybe write that particular box image of red, and then you can place the blue box there, and that would be your choice, where specific area you need to identify first, and then you need to see the coordinates of those area where you need to put the box, and then you can just place it with the blue box. So for that we need to import from pale image and image draw. and then image is equal to image new, and then RGBA, and then 200 white, and then when I would be drawing it. So what I'm doing here is 100,000, 180, and 180 specific coordinates, up, left, right, and bottom, and what would be the color of the particular box what we want to set in the specific image. That would be the draw, and then on the image we can save it rectangle dot png. We can put that particular box on the image as well, but for just to show you an example, so let's see the results now. Also with the exercise, I want you to go through these different filters, and after applying those filters, maybe you can perform some more functions as well. Maybe after identifying the contour, maybe you can resize it, and after resizing it, maybe you want to uh, replace some values with your declared values, and you can play around with these filters to get a better understanding and working of the specific functions of the PIL library. And in the start it would be a better understanding for you that how to deal with the image, manipulate it, and what are the different kinds of functions. So that would be a basic operation in the Python, like by using PIL. The most important in that area image processing would be openCV, because in that area like around 25,000 people are working on that particular area, and there are a lot of stuff available, which people are doing in different areas, maybe tracking, object measurement, distance measurement, and alphabets measurement, then hand measurement. So there are a lot of things. So we will gonna pursue from tomorrow with the openCV, starting from basics, and then maybe we can move towards the object measurement and the distance measurement. So let's say we can open the Jupyter now. So from here we can maybe import it, and then if I just want to see, just give me a second. Okay, so now, so that would be image, and then I want to open a particular image. Maybe I have multiple in my Jupyter directory, maybe animal.jpg, and then I can image.show. So in that area, or maybe I can print what I was showing you, that we can see the result of the image size, image format, and the mode as well. So that would be image size, and then maybe image dot mode. I think I have put it correctly. So as you can see, okay, let me share another screen with you. So here would be a result. So yeah, so as you can see, there is a specific another image, and there is the 1280 cross 720, and then RGB, and then that would be a separate. Oh, you can watch my screen, right?
Yes, sure.
Okay, that's perfect. Okay, I was confused. Okay, so as you can see that that was the specific size of the image, and what was the format. It was JPEG picture, and then what is the mode? It is the RGB. Now, as I was telling you, maybe you can now do some operations by resizing it. So if you just resize, it's built-in functions, and then you can, if that is the 1280 to 7, maybe you can put it in a square format like 400 cross 400, and then you can just put it out here. So Yeah, so as you can see, that would be a image, resized, and I can play around with whatever specific size I'm required to. And then again, if I want to rotate it, maybe. So one is equal to dot rotate is a built-in function as well. And then what is the specific angle where I need to
45.
rotate it? So it would be out one. So run again. So as you can see, at the 45-degree angle, it is rotated, and maybe we can see it in from the different angles. So it can be rotated till 360. So that is another example. Maybe and now if yeah, one more thing I want to show you that would be a very interesting one for you. So if you want to transpose the image, like the mirror image or the up down format, so in that you need to do dot flip. Yeah, so there are a number of options here. Okay, let's say if I just want to flip left or right, and then I just declare it in the out. So there would be okay, well, I think that would be confusing. It is flip left, right, but the picture is uh, a difficult one to understand. That maybe we can declare it bird here. So if we were to just see bird here, that would be the specific bird. And now in the out area, we want to declare it. So yeah, now I want you to differentiate between that bird. So as you can see now, it would be more clear because in that particular case, that is a different picture, but these are two different maybe. So as you can see, so it is flipped on the other side. So with the same pattern, you can move it like the up and down as well. So maybe we can just, or maybe you can replace flip left with the top bottom, and in that particular case it would be the opposite of that image, starting from the upper and lower. So there is the one example of transposing an image that would be a useful function in so many projects. So now let's say what I was identifying there is okay, now what we want to do is maybe we want to crop a specific portion of the image. So if I say now, if I want to say maybe 400 from the left and then 300 from the upper side, then again 700, then again 500, and then we have our region is equal to im dot crop. Here is the function, and what I'm cropping here is I've already defined above, so that would be a box. So if I just maybe put here the region, then there would be a specific portion of the image. Okay, well that should be okay. Yeah, that should be replaced as well, like the bird, and that should be maybe animal, because we have bigger pixels in that particular pictures, like the one at 1280 cross 720, and in that picture we have a limited portion. Okay, so that is giving me okay. Let's say if I just put it there. We have a box and we have set the values there, and then there is the image.im dot crop, and im we have defined already there. And there is image.show, and if we, okay, so here is the problem. Yeah, perfect. So yeah, that would be the specific image which we have declared above. So perfect. Okay. So as you can see, that was the real picture, or maybe we can see it by this window here, and then we want to crop a specific portion, and so that would be according to those values, and you can set according to your requirement from where. Yeah, you can, Christian, you can see the properties of the image as well, but maybe when you will be dealing with different images at the same time, because currently it's just to give you an idea, but you will be dealing with multiple images at the same time. So maybe if you want to perform a function that, okay, in that specific folder, there would be like 50 to 60 images, and you want to perform a single function on all of that at the same time. Now you don't know that what would be the specific size of every single image, and so you can just apply the same function to the specific images of the folder. So in that particular case, you can do this thing. So for now, it is just to analyze that, okay, what are the specific values we can see from the I mean by Python, by using the Pale library. You can see the properties, all of those properties maybe from the. Okay, yeah, again, so here you can see. So how do you select the size of the cropped image? Okay, let me show you. So that was our real image. If that was not transposed, let's say if that is a real image, so now what you want to see, you want to crop that particular area. Now it's all about trying the different numbers. So it is somewhere between, if we talk about the horizontal and vertically, below, a little bit below the center, if we just talk about the faces. So now, according to that, now you know from the very beginning that the image size is um, 12 1218 to 720. So according to that, now you should gonna start from the, maybe, okay, let's say if I want to change here maybe 100, so the specific left side values would be a very initial level. So if I say this one, so as you can see here, so it is starting from that particular pixel, from the left area, like after I mean, when I was putting 400 values, it was somewhere here. Now if I want to see, okay, because it's the value of left 100, so it is getting more of it. Now, for example, I can, maybe if I put it 0 here, so it should be starting from, yeah, so as you can see, it is starting from the very beginning. So it's just about the numbers. You can I mean put the values according to your specific region that you need to get from that particular picture. Okay, I think I'm clear. Let's move a little bit forward. Yeah, it's a perfect. That's great. So, okay, yeah, so maybe if we change it again, because we need to perform a specific functionality with that region. So, what I want to do here is, now maybe I want to put that particular box what I have extracted from the real image back to the real image. How? Now, let's see. Region again is equal to region, and then we can transpose it maybe. And again, now here is the part, I can do it, or it's totally dependent on the requirement. So there are number of rotations here. So maybe if I just flip it up down, so that would be 180. And then if I image and I paste it, what I need to paste? I need to paste that particular region, what we got from the box we have defined above. So if we put it there, and then so that would be image dot paste. Maybe if we declare image here, I'm not correct. Okay. Okay. So there is the specific area, and that area is rotated. But I want to see the real image as well here. What was the specific region? That was the region, and image should be different here. So yep. Okay. So maybe if we do it this, and then we can just place it here. No, man, it would be difficult. Okay, if that particular region, and we need to see the values of that as well, like it can be replaced there, or maybe we can do image dot show as well. So if we do this particular area, so again that would be the image. Okay, that is I think I need to, I have done it with the bird image, and now I'm doing it with the animal. So let me say into it. Let me get back to you. Okay, so again, let's see it. So that is a specific region, and you can place it on the image as well, like region dot transpose and image dot rotate. That is perfect, because as you can see here, that region is rotated, what we have identified above. Yep. Okay. Okay, let's move forward. I am gonna show you the result of the particular box extracted from a picture and then rotated and then pasted back to the original image, and then original image with the box. So I am gonna show you that as well. So let's say for now we can also move with the other filters as well, like let's say if I want to see here image blur maybe. So image dot, so we have built-in function with the filter, and then there is a image filter dot blur. So in that particular image, it would be most probably what we have defined it is. So as you can see, that was the real image, and that is the blurred image. And you can see the difference between the blur. So again, so yeah, so now I want to show you again as well, maybe the previous function. If I see it in the example, that the transpose. So yep. Okay, so here is the animal image dot jpeg, and we have seen that all the values are correctly identified. Like I'm not supposed to set the value in the box more than 720 or 1280. And now this image is used in so many other operations as well. But what we want to do, we just want to perform this box 400, 300, 700, 500, like left, upper, right, lower, and that would be the particular area. So again, if we see, okay, perfect. And then if we run this one, so yeah, okay, perfect. So yeah, that was the thing I wanted to discuss with you, that it's of no sense. I mean, yeah, the picture is making no sense, but yeah, there is an operation that you can perform, that you can extract the specific portion of the image, and then maybe you can rotate it, and then you can paste it on the same picture as well. Maybe in many few cases you will be gonna needing it, maybe by putting or copying a object in the image, by numbering. Maybe you want to place there 4 or 5 objects instead of one, so you can just crop that particular object from the picture, and then you can replace the same you can say object one by one. So again, now what we were doing there is we can performing the image filter, which is blur. And then here again, maybe if I just want to see the contour, so yeah, so as you can see that there is a particular shape, but it's not looking good. What I think in that, the in because that picture there are a lot of different values of colors, or the object is not very clear from the camera perspective. So maybe if we want to have a picture of bird there, and then maybe if we run that, and if we find the contour of that particular bird, so yeah, so as you can see, that is the particular shape of that bird. And we can see of different images as well there. Maybe with the one more image I have here is one. Yeah, so in that particular case there would be a contour of maybe a little bit more precise. Yeah. So so yeah, as you can see in that particular case, that contour, or you can say the shape of the bird, as currently you can see in the picture, as far as the image would be more clear, so you are able to find a better result of the contour, that what is the exact shape and where is it I mean going from. So that was the example, two examples of the you can perform contour detection, you can perform blurring the picture, and you can perform multiple other filters are available as well. As I have put those in the exercise area. So now what we want to do, we maybe yeah, so if we talk about the pill library, so from the pill library you need to firstly import well, I have already imported the other functions, but when you want to draw something, as I said in the watermark, we put specific you can say our sign or our logo on the picture in order to make it unique, that it belongs to a specific person or it belongs to a specific maybe company. So now firstly, if we talk about create an image object, maybe. So okay, now we can maybe identify here same picture or the different one. Okay, maybe a different one we can place here. Let's start, and then we can open, and then the same, the other one would be more better. There is wild and there is bird. So we can open the image, and then we need to set the size. As you knew about, the width and length would be should be equal to the size, like as I was showing you that the size of the previous animal picture was 1280 into 720. So maybe because we will gonna need the width and height when we want to set the particular text in the image. So we will gonna need that, okay, in what specific location that text should be placed on the image. So if I say width and then maybe a height, and then there, that would be equal to the size. Okay, yeah, I think so. So maybe now you can draw with that function what we have declared above, image draw, and where we need to draw it on the image, and that image is placed in IM. So and then what is the particular text I want to add on the particular picture? Maybe I can put it and put my name there. And then if I want to set the font is equal to image, and for that we also have a particular function, image font. We can find it here. So that would be the image font dot. So from here, yeah, to type, and what would be the specific size and the style of that font what I need to define on the picture. So maybe I can put it Arial here dot f, or then again what should be the size, how bigger it should be. That would be 36, and then I have text weight. Okay, the above one is the width and height of the particular picture, and then maybe we can set the text. And okay, that should be the height now. And then maybe you can draw the text size here. Width would be okay. Now we have already defined above that what should be the text and what should be the size of font of that part. Okay, maybe we can, okay, bird is not defined. Yep, perfect. Ah, yeah, so that is the mistake. Okay, as you can see, we should not call it like that. Okay, I have pressed a wrong key there. Which one is that? Yep. So that was bird. So it should run now. Yeah, perfect. Okay. Okay, so there is the specific text, and we have set everything, and it is working till now. And then what we want to do, where should I place the specific text? Now I have the height and width of the text, and I have the width and height of the image as well. So maybe I can place it in the X or Y. In the X, I say width, that is from the image, and then the text width, that is from the text, and then maybe margin from what should be the margin left from the corner. So if we put it here, y is equal to, then I have the height, then I have the text height, and then again the margin. Okay, so these are the x and y values. Now simply I just want to draw dot text. Well, its output would be very simple, and its efforts are more than that. So but yeah, it would be an example for you. So if we take draw text, and we have set the orderly values of the x and y, and then there would be a text, and then font should be equal to what we have declared above as the name of font as well. and then I can show image dot show. Okay, that's perfect. Or I can save it as well, but I don't know whether it's gonna, yeah, perfect. Okay, so we did not define the margin. Why? Okay, okay. So yeah, we can define the margin as well. What should be the value that should be left from the corner, or from what value was specific? Maybe we can put it 10 there. So yeah, okay, perfect. So as you can see here, finally we got the result, and that is the only changing what we have done. But yeah, in most of the cases, it is important that you have a specific a name placed on that picture, and then after that, when the picture would be saved, so that name would be ever placed in that particular picture. So that was the example of watermark, and then maybe you can save that picture, and after that you can, if a photographer is shooting maybe some photographs from on marriage or anywhere else, and if we put that particular logo on every image, and when okay, that is the question again, Habimana, as you were asking the same question. Sorry, not Habimana, Christian. So, in the case of that particular photographer, when he wants to do that thing, so he will not gonna do it with the single image. So he will gonna apply the same function on all of the images that would be placed in a particular folder. He will just gonna give the address of that particular folder, and then he wants to apply by maybe looping on every single image. A single function should be performed, like the name of Osama at that particular text, and it would be saved. So you can image dot save as well. So maybe there is image dot save, and then what should be the specific name, then you can maybe place here Sama photography, and then it would be a specific case of the watermark. So again, now let's move forward. It was a lengthy example. Now, maybe now let's see an example of setting the different bands. I mean, red, green, or blue of the single image. So for that, maybe when we talk about the image of white, so we that is a very useful library there, and then maybe we can define an image is equal to image u. Yup, and then okay, that's great, and then image read, and then you can perform okay. Oh well, you just need to get the specific maybe okay, if you say that if you want to place a specific text in the center of the image, well, first of all, there are particular images, but usually photographers do not prefer that should be placed in the middle. But yeah, in some cases I have also seen that. But you just need to calculate the x and y coordinates. So maybe if you have a width of the whole image, that was maybe there was a height and there was a width, and maybe the width was 720 and there was a specific height. So what you need to do is you need to identify where your text should be placed. So what I have done here is width minus text width minus margin. So it should be the corner, like the whole width should be should also should only minus the text width. What is Osama? Like, let me show you from the code as well. So here, how we have calculated that Osama should be placed here, that I have subtracted the text width, that is the whole text, what the specific width this is taking, and then the margin, like here, of the 10, and then the whole width minus this. So that should be the starting point of the specific portion. And if you want to place it somewhere in the between, so you just need to identify the x and y coordinate. Maybe dividing by 2, there would be a specific result, and if image would be square, then there would be a different result, and if image would be maybe horizontally it is big and vertically it is less then the width. So there you just need to find a formula or need to define there what should be the specific place, and you need to perform the same functionality that you have a width of the image and then you have a width of the text, and now you want to place it somewhere in the picture, and if you want to put it in the middle, then there would be a specific yeah, you can say by divided by 2 most probably with the, and then you can extract the text width. Maybe you should not need to define in that particular case margin, so it would be in between, and then on the same in the same area you need to perform it with the height as well. So there would be a specific result. uh, but I mean that would be a good example for you. Maybe you can just set the values there, width and text width. You just need to change those. You don't need to play with anything else there, like the text width, like these values. So that would be a great example for you. Maybe you can do it with the you can say so how to put it in the center, how to put it in the left corner, upper corner, or if you're done with that, maybe you could do with the other examples, but it would be a great example for you to calculate where your text should be placed. Okay, perfect. What need, I was thinking here. Okay, yeah, we need to define the particular color. So if I say, okay, again, I'm doing the same mistake. That should be placed here. And okay, if I want this, yeah, thank you so much, image you. So that is incorrect, and that is the correct one. That would be EI. Yep, perfect. Okay, yeah. So again, you can maybe write you. So you already have a real image. Okay, I can get the specific that is also working somehow. So if I just put it there, maybe. Okay, perfect. So we just run it. Yeah. Yeah, okay. So as you can see, sometimes it replaces the comma with the English comma, you can say. Okay, so in that particular case, now you have a red image. Okay, that is the thing what I was showing you, and we are saving the image, and now what I need to do it is here, image dot image dot open, and what we have saved, as you can see here, there is the same code, but I can repeat it again by showing you the result as well. So if we have saved them, that should be placed somewhere. Here is the red image, and then maybe image dot show. So if we run this, yeah, perfect. Okay, JPEG image file object has no attribute image. Okay, we run that, and then okay, yeah, then there was a image. Why is that? Okay, if I, okay, that is the maybe attribute. So we can save multiple pictures there, and okay, now we have opened a lot of pictures. We need to somehow remove all the others. So yeah, okay. As you can see, here is what I'm doing here is Like the image is equal to image, we have already read the bird image, and then we are separating every single color, like the red with the zero, green with the one, and blue with the two, whatever the other values are. So, and then a red image is equal to image copy. We already have that image and we have copied it, and in that particular image, what we are performing, we are performing that red image, the one sorry, one band should be equal to 0, and what is 1 here is green, and then again the 2 is blue, and all of the values of that particular image should be 0, and then we can save that red image. Now what if I show you, because I think yeah, if we are writing image right, so that red image is also present there. I want to show you the result of that red image as well. Sorry. So there is the red image, but it is looking like that because we haven't set the values of blue and green in the till then. So if I, when we will be setting the all of those blue and green values should be equal to 0, not anything else, then there would be a specific result in red cases of that. The only red color would be placed here. So again, if I want to do it with the blue color, maybe I want to access the blue color and remove the red and green. So in that particular area, now let's see, red belongs to 0, green belongs to 1, and blue belongs to 2. And here, now what I want to do is maybe we can do it with green now, and it should be green as well, and that the other one should be green as well. So here now in the green image, as you can see that green belongs to 1. So what I need to do is we need to set the values of red, that should be equal to 0, and 2, that is blue, should be equal to 0. And if we, when we want to save that particular image, maybe we can do green image.jpg. So most probably it should give me a particular result. Okay, it's JPEG, and now let's see what's gonna happen. There is the one example. Okay, let's see. So image, right,
Osama, maybe image we are still read image read.
from here,
No, up.
yeah. Sorry, just a second. I think it's image, green image is equal to copy, and then there is values, and then there was a green, and that was 1, and okay, yeah, perfect. Yeah, so that is, that should be the green what I am doing there. So that should be the green image, not the red one, most probably, and that should be so perfect. Okay, so yeah, so that there was a green what we have defined there above, and then we can, when we can perform on that particular image, that okay, all the values of red and blue should be 0, as you can see there. So only the value of the green, that is the 1, and that would be the specific result in terms of green, and that is the result of red. So and similarly you can do it with the blue as well.
So can you go some to your code?
Yep, sure. Now, yeah.
I have some requests to participate maybe. Osama use image.copy. There are two approaches in copy image. Either you copy all image or copy the reference image. Can you test in your code what different type of copy we need and what is the difference? Maybe some homework for students who attended to this course to understand the idea about copying. Because sometimes we have to handle this memory management. Sometimes it's like a shallow copy or deep copy. So my request to practice now, maybe now some I request to let the fellow do the practice in their own. That means they have to do this by them. And this is like good because we not to reduce as much of effort because we need to handle everything by them and that they feel how it's working with company. It's better not to jump to next exercise before they have a good experience how to handle it. Tomorrow, by the way, I try to cover some of this aspect as feature and what is how it's used. So now my request for all of you to start to practice now by coding by yourself. That means everyone have Jupyter Note or Google Colab. You can know how to set up the environment and then set up the Python with openCV if you want, or you can use all the environment. Just you need to set up the openCV library. Then let's go with your code.
Sir, I have one thing to say. There is a question regarding the 0 and 1. So the 0 and 1 values, though that is a one concept, and when we talk about the RGB, there are three different channels. For red, there would be a different value, green, there would be a different, and similar for the blue as well. So, sir, if you can answer that particular question, it would be more
Okay.
better. Yeah.
Okay. So as you mentioned in color mode, you have three modes. RGB for RGB mode, sorry, for color mapping. Our color styling. We have RGB, and that means we have three layer, three channel. If you want to, that means this is the depth of basic cube. You have wide and depth, and we have go and depth. Every one depth is like one layer. That means one channel. That means we counting like channel like 0, 1, 2. If you have etc channel for transparency, that means it is 3. If you have depth information, it's like 4. If you have etc filter layer is 5, and go ahead. So that means the first 0 is what is meaning is red. The second is the green. The third is blue. And take in your consideration OpenCV take like the RGB, not like here we using image input output to read. Now we can use the next is mostly about OpenCV. Maybe this is good practice because here we're using the true RGB image, but on OpenCV we're using the first channel is the blue, the second channel is the green, the third channel is red. Tomorrow, I will describe this in detail with some. I give you overview. What is the benefit about color map and what we can use it. I hope this is clear to everyone. Now, my request to start read some file. Maybe I will and start by yourself to handle this. Maybe now we have some overview how it's like looking. Maybe this should be start some practice. Okay. I request also for Kali to is update about the Google Drive because till now I don't have this permission. If this update, let me know, then I can upload the video directly to this file. Otherwise, I wait till Kali they inform me about the situation about the Google Drive. Okay.
Recording stopped.
So now the picture somehow we are close. Now we are at the end. So somehow that means we spent good practice now, and now this should be start by yourself to practice. Tomorrow we'll go ahead and we'll practice more in openCV. Today we found their answer library is image or input output. We have to set up this image. Maybe this is start some basic for you. Maybe you Google it. Maybe you can use pip install image input output. It's easy for you. I guess this mostly is like easy. And the idea about this is how to handle this. Maybe the more important aspect you have to take in your consideration how to understand how to handle image and to write some basic features. Then we go deeply, and this is many common applications coming quick about the image processing and connect to deep learning engineering. Okay, any question?
No question.
Yeah, I had one.
Yeah, go ahead, Christian.
Yeah, about P image modes and the other image mode. What is the difference between the two?
Can you repeat the sound? It's not clear. There are some noisy background.
It is like the question I wrote in the chat bot. I was like to get the difference between the palette versus grayscale.
Okay. In grayscale, we have one channel. That means we not only we have one layer. That means something like this. We can make simple like suppose we have like image with different layers. Suppose this image and this is paper is like image. If they are grayscale, I have only one paper. If you have this color, I have like three paper. Okay. So in grayscale, I have only one paper, and this is like and each pixel represented between value between 0 to 2055. So that means based on this value, the 0 will make black. And if you want, you can infer this value, depending about your representation. And the one is the 25 is the big value. Now, in case we have three layers, that means we have three value about this, and this overlapping. That means this index 0, this index 1, this index 2. Now, if you want to access the index 0, that means access this. If you want to access the 1, that means this. If you want to access 2, this is this. Merging the value, overlapping all value 0, 1, and 2 in this pixel, like when you draw and biting, you get the color image. Number of pixels, number of coloring, extend the possibility how much true color. And each pixel can represent an 8 bit. That means for 3 bit, for channel red, gray, and blue, we have 8 multiplied by 3. That means we have 24 bit represents 1 pixel. That means if you have every pixel you have the value between 0 to 25. That means this is the value between 24 power to 25 6 because we counting from 0, not from 1. That means we are around about 160 million, 70, 70, 32, around this. This is number of color can be represented if you take data for encoding only 8 bits for every pixel. If you increase the encoding, that means we get more coloring. This is the idea about sometimes how much color we can see in computer. Depend about how much of value we can encode the color. For example, if you do simple, if you take a grayscale, that means if you take like the color is like a gradient between 0 and 1, or between 0 and 25. Maybe let me if you can Google it. Maybe. Scale, color. So I will share screen. This is what we see. This is how it started. For example, this 0, maybe 10, 20, 22, maybe 1, 255. This is how it's like. This is how it's looking. Maybe if you grayscale image, you can find this is the value. This is the gradient value. And if you want to grayscale color 0, let's check if there are 0 to 25. Sorry. We can find something like this. This is 0. This is how is 64, 128, 192, 255. Okay, that means if the file, if this is grayscale, I have only this layer. If you have not grayscale, I have 3 layers. And overlapping each other, I get the true image. Something like this. I have image, I have 3 layers, and this is like red, green. But computer doesn't see something like this. The computer sees something like 0 between 0 and 25, 0 between 25, 0 between 25. Merging all together get a file, and this file some representation how it will be look. Something like this. and this is the same idea. Because I hope this is makes some example. No, this is like a huge explanation. Something like this. This is visual light, and this is how it's looking. If you have this, this is the complete standard solid line, and this is how go from 0 to 9. And sometimes if you go for some maybe Photoshop online, maybe so if I make a new image, just make like this. So and I change the color here. You can find. I give, for example, if I make this is like you see. Can you, if you're looking here, this is the amount when I looking. This is the thing, they have this amount of red, this amount of green, this amount of blue. The same situation have amount of saturation, huge saturation brightness. Okay? Is it clear now, Christian? That means merge all this color, I get the file. That means if you go, you can see how it's changing. And white, how much in white? In white, we have the light, the color here is like 255, 255, 355. If you want to take one black, somehow it's almost black. You can find it's more close to 0. That means if you get this, is all 0. It's take blue. I want to take more blue. Maybe this is somehow go blue. Maybe if you can get something like this, it's completely green, completely blue, completely red. But if you go, we can find the gradient of color is mixing between 3 different colors. This is the RGB is the one standardized. Maybe white use it. Other approach is use saturation value, or there are other approach also by the way. But this white use it is RGB. Is it clear now, Christian?
Yeah, it is clear. It is clear. Thank you.
Okay. So I start tomorrow with this operation. I understand who is not experienced computer vision, we have some problem in this. So tomorrow I will go ahead and show in some basics, but later we have to go on advanced step. Okay? In case no other question, I will thank Osama for his presentation. I will close today's session, wishing you have a nice day, put to practice, and I try to upload the record after it's converted. Okay? Maybe the missing record from last week, I will be doing this later. Okay? When everything is fixed with Google Drive. Okay? I try to find also other converter which is convert the video to other format with low size, by the way.
On that note, Serge said that he bought some space on Google Drive. Maybe we will soon share it with you.
Yeah, okay, will be the great. When I get this.
Yes, sir. I have already uploaded that file. Maybe in the few moments, you can upload that file.
Okay. I need also to convert my file, because when I close session with Zoom, I start converting, and sometimes I need 1 hour or 2 hours, depending about the free space in my drive, and then I upload it to all. Okay. In case there's no question, thank you for this hand. I'm waiting the feedback from Serge, and if case no question, I hope you have a nice day. Wishing you all best, and meet you tomorrow in the same time. Okay?
Okay.